Okay, in this video I'm going to teach you how to tackle any conditional probability example. So pay attention, this video will be a little bit longer than I'd like, but if you follow along, everything should go great. First thing, write these formulas down. So the probability of event A given, which is by this line, given event B, so the probability of A given event B equals the probability of event A and B all over the probability of just event B. And we have another formula, so probability of event B given event A equals the probability of event B given, or probability of event B and A all over probability of A. So to memorize these formulas, the last event, which is after this line, is always at the denominator. Okay, so after you memorize these formulas, you need to draw a contingency table. And a contingency table is just showing a relationship between two categorical variables. And in this case, it's going to be pets and children. So let's read the entire problem without stopping. In Ohio, 45% of all households have at least one pet. Also, if a household has at least one pet, the chance that children are part of the household is 87%. If a household does not have pets, the chance the children are not part of the household is 75%. Answering the following questions. So that's really wordy. Hate that, but it's not that hard, trust me. So let's draw our contingency table. So we do this. I know they're not really spaced out that nicely, but I am obviously not an artist. So we're going to have our totals down here and total up here. And our variables were pets and children. So pet, no pet, children, no children. So let's read this problem. In Ohio, 45% of all households have at least one pet. In that first sentence, they're not saying anything about some variable given this, given that. It's just, of all households, 45% have at least one pet. So that's our total for the pet category. So go down here, pet 0.45. It's also important to note that everything's going to add up to 1. So you could do some algebra right here and figure out what's the no pets in Ohio. So if 45% of households have at least one pet, what's the probability of having no pets in all the households in Ohio? So 1 minus 0.45, 0.55. Pretty easy. So let's keep reading. So also, if a household has at least one pet, so there's our given, at least one pet. So that's going to come after this line. So that could be event B if you want to say. The chance that children are part of the household is 87%. So the probability of having children in the household, given, once again coming after that line, having at least one pet, so I'll just write pet, equals the probability of children and pet. So probability of, I'll write C as children, probability of children and pet all over the probability of just having a pet. So what does the probability of children given pet equal? It equals 0.87 or 87%. So I'll write that probability of children given pet equals 0.87. What's the probability of just having pet in Ohio? So just the event P, or pet, come down here, it's 0.45. Obviously, we don't know what the probability of having having children and pet in the household, because we go here in our contingency table, pet and children. There's nothing in this blank. There's nothing there. So we're going to solve for that. So if you set this up, it'll be 0.87, which is the children given pet, is equal to the probability of children and pet all over just the probability of having a pet, and that's 0.45. You are going to multiply 0.87 times 0.45, which is just basic algebra. In order to get the numerator, you multiply the denominator and this number over here to get the numerator. And that's going to equal, I should have calculated this out first, but I didn't. 0.45 times 0.87 is 0.3915. So 0.3915. Okay, so that's it for this part. Let's keep reading. If a household does not have pets, the chance that children are not part of the household is 75%. So what's our given? If a household does not have pets, that's our given. So that's going to come after the bar, after that line right here. It's going to go here, probably not having pets. So, in not having children. So, chance that children are not part. So, it's both not. Kind of like a double negative there. So, probability, no children, given that we have no pets, equals 75% or 0.75. And once again, we're going to use this part of the formula like we did up here. So the probability of no children, given that we have no pets, equals, I'm going to use C as children and P as pets again because I don't have enough room to write all that out. And if I did, it'd look really sloppy, and my handwriting is already sloppy. So, probability of no children and no pets all over the probability of not having pets, so no P. And that's what we solved for down here, this, which is 0.55. So we're going to plug in our numbers into our variables. So no children given no pets is 0.75 equals probability of no children and no pets all over the probability of not having pets, which is 0.55. And like we did up here, we're going to multiply 0.75 and 0.55. So we're going to multiply that. And that's going to be 0.75 times 0.55, 0.4125. Where do we put that at? Well, no pet, no children. It'll go in here. 0.4125. Now I think we can solve for everything. All right, so how do we do that? So let's just focus on this column. If we look down vertically, the total of having no pets is 0.55 and no children is 0.4125. So how do we find the children no pet? Well, you just do 0.55 minus 0.4125. So that's 0.1375. Let's look at this column right here. The total is 0.45. The pet and children is 0.3915. So 0.45 minus 0.3915 is 0.0585. So how do we find the totals? Well, we just add these up right here. So we're going to add this and this to get this, this and this to get this. So 0.3915 plus 0.1375 is 0.529. And the one below that, 0.0585 plus 0.4125 is 0.471. Oops, 0.4. Come on. This video is already long. 0.471. Like I said earlier, if we add these up, it should equal 1. So 0.529 plus 0.471. What do you know? That equals 1. I just put it in my calculator, double check. You would think I should have done that in my head, but oh well. So let's answer the questions now. We have this huge contingent, not really huge, but you know what I'm talking about. Anyways, we got all these numbers here. So what is the probability that a household has at least one pet and children? So we go to the pet and children. That's 0.3915. That's your answer. So what's the probability that a household has at least one pet and children? A is 0.3915. So let me come down here. So A is 0.3915. Okay, what is the probability that there are children in the household? So just children. Probability of children, well, 0.3915 plus 0.1375. There are a total of 0.529 children in the household. Obviously not, it's not a fraction of a child, but percentage-wise, that's how many children are in the households. So, B, 0.529. Let's look at C. This is where it gets a little bit more difficult and why there's two different ways of representing these formulas. So, this formula and this formula. So, given that a household has no pets, so that once again, there's our given, so we have no pets. What is the probability that they have children? So let's come down here and write this down. Let's see if I can keep that up so I can see it. So the probability that a household has no pets, so it comes after the bar, no pets, but they have children. I'll say children. Oops, children. Okay, and this equals the probability of children and no pets all over the probability of having no pets. Okay, so what's the probability of having children and no pets? We come over here, children and no pets, that's 0.1375. So the probability of children, no pets, equals, so probability of children and no pets, 0.1375. Probability of having no pets, so no pets right here, 0.55. So we'll divide those two. And that is equal to 0.25. That's your answer for C. So C is 0.25. Okay, let's look at example D. If we scroll up here, it says, given that a household has children, what is the probability that they have no pets? So how does that differ from C? Well, if you read the first part, in C, it says, given that a household has no pets, but in D, given that a household has children. So when I said there's two different formulas, that's what I meant. We are changing what the event is. So in this formula, we are dividing by B, and in this formula, we're dividing by A. That is why in C, we divided by pets because it's given, and in D, we're going to divide by children because that's what's given, and that's what's going to give us a different answer, a different value when we solve for the probability of them having no pets. So let's do that. Given that a household has children, what is the probability that they have no pets? So that comes after the bar. So children, no pets. That equals probability of no pets times, or just and, which is the same thing, times probability of children, all over just the probability of children. Okay, So what is the probability of having no pets and children? We're going to go up to our contingency table, no pets and children. That's 0.1375, just like we had up here. So 0.1375, but in this case we're dividing by total number of children, which is 0.529, but in C we divided by the total number of no pets. So that total number of children in this case is 0.529. 0.529. Let me write this again. No pets given children equals that, and our final answer is 0.137 divided by 0.529, which equals 0.2599. Yes, they're close, but that's not always the case. So if you follow exactly what I taught you, then you should do great. But if there's any questions or any problems you're having, comment down below and I'll be sure to answer them. Well, hope this video helped, and please subscribe and like the video so other people can see it, and just hope everyone does well.